Hello, my name is Mark Lemieux. I'm an engineer at H&TB, based out of H&TB's Technology Center in Kansas City. Today we're going to look at a presentation on InRoads XM Edition End Area Volumes Tool. In today's agenda, we're going to cover quite a bit in the End Area Volume Tool. We're going to look at some of the different volume computation methods available in InRoads. We're going to look at how to use the End Area Volume Tool to do normal cut and fill between surfaces. We're going to flip over and look at the annotation and XML reports that are available from that cut and fill surface. We're going to look at the preferences and end area volume files that could be used to reprocess the end area volumes at a later date if desired. We're going to look at how to incorporate proposed components from our design surface into our cut and fill volumes. We're also going to look at how to incorporate non-standard existing materials into our cut and fill volumes. And finally, we want to look at the classifications leaf of the end area volume tool in a little extra detail. InRoads has a few different methods for computing volumes. There's the triangle volume tool, the triangle volume by station tool, the grid volume, and finally the one we want to look at, which is the end area volume tool. I don't want to spend a lot of time looking at these other tools. I want you to be aware that they exist, and that's about it for this presentation. So if we look over in our MicroStation file with InRoads, we can see for volumes we have the triangle volume by station, grid volume. We're going to skip all those today and we're going to skip right down to the end area volume tool. To use the end area volume tool, the cross sections must be displayed in the CAD file with the existing and design surfaces. To calculate the volume between two consecutive cross sections, InRoads averages the areas of similar materials between the sections and then multiplies by the length between the section to determine the volume. This process is repeated between each set of sections that are shown in the design file, thus coming up with total volume for the sections. At this point, let's create some real basic cut and fill earthwork volumes. We've already got some information set up for an example. This information consists of an existing surface and an ALG file with proposed horizontal and vertical alignments in it. I also have set up the roadway designer with template drops along one of my horizontal and vertical alignments. So what we're going to do is we're going to take this information, create a proposed surface, and then with the existing and proposed surface, create some cross sections. Let's jump over to MicroStation and do that. You can see I already have an existing surface open. If I want, I can review and maybe look at the perimeter of that surface. You can get an idea where this existing surface extent lays out. I also notice in my MicroStation file I have an existing alignment that's in the north-south direction. I'm going to be creating sections along this proposed alignment called PSJ in the east-west direction. And this proposed alignment goes up and over the existing north-south alignment. If I go into my roadway designer, I can see I already have this PSJ corridor created, and I've got template drops along this corridor. Now what I'm going to do is look at one of these drops, and if I double click on these different components, you can see I have styles associated with the components. This style for the component I just picked is base course. The style for the top is friction course. I also have base course for different areas. So I've got components, multiple components, some with the same style and some with different styles. Base course, friction course, structural course, so on and so forth. So let's create my proposed surface. I only need to do this for PSJ. So now that my surface has been created, I'm going to close this dialog box, and I'm done with the roadway designer for the time being. Notice the PSJ surface was created in my surfaces list, and I can save this surface if I want to. And we'll save it as PSJ. And just to get an idea where that surface lives, Let's view the perimeter of that surface as well. And if you zoom in, you can see I have this new white line to show the perimeter of that proposed surface. So we can turn this off now too, and close this down. At this point, we're ready to start creating some cross sections that show my existing and proposed surface information in it, or in them. Instead of creating cross sections exactly at every station, I've created some planimetric lines previously, and the reason I've done so is so I don't cut a section in the area of my bridge over my existing north-south alignment. So I'm going to jump out here, and I'm going to pick my planimetric lines. When I open up my cross-section, create cross-section tool, I'm going to use a preference for sections, and I'm going to bring in the graphics of those line strings. I'm also going to check my general tab, and I notice that my PSJ surface and my existing right now are going to appear the same symbology. Let's change the PSJ so it looks a little bit different than my existing. I'm going to change the cross-section symbology to design, just so it looks a little bit better in the section. When I hit apply, I can create these cross-sections anywhere on my screen, and I can close the create cross-section dialog box. If you're going to zoom in on the sections, you can see the existing ground in white and the proposed surface in red. At this point, we're ready to start using the end area volume tool to create some volumes. First, we'll reopen the end area volume tool. If we choose the general leaf, we'll notice some of the basic information for using this tool. First, we can see the cross-section set being processed. If we had multiple cross-section sets, we could choose them here. We only have one, so this is the only one we can use. We see the different surfaces in our current cross-sections. We have an existing surface and a proposed or designed PSJ surface. We see the different methods for computing the volumes between our cross-sections. The standard method simply uses the distance between the cross-sections for calculating the volumes, whereas the correct for curvature uses the centroids of the various areas for calculating the volumes. This would be more critical if we had an alignment with curves in the alignment where the areas of the materials are either on the inside or the outside of the curve, in which case the length between the section would be different than the length between the centroids along these curve values. We can apply station limits to the cross sections that we want to calculate the volumes for. We can ignore areas smaller than a certain amount. We can choose our units. Do we want to have the annotation displayed as cubic yards or cubic feet? And finally, we can create an XML report if we choose to. If we look at the classifications leaf, we'll see that we simply have one object at this time. This is the minimum amount of information necessary to do end area volumes. We mentioned previously that we had a volume exception to put in where the bridge for the designed PSJ went over the existing north-south road. Let's add that information in now. If I choose volume exceptions, I can choose a start and stop station. Well, in this case, I might not know what that is just yet. So I'm going to come over and I'm going to do some tracking on my alignment to determine the planimetric lines for my volume exception. If I use my tracking tool, I'll notice that this is a station of 9879 and this has a station of 10121. So we'll choose those stations in our settings. 9879, and 10121. With that information entered, we'll hit add to enter it into the volume exceptions to be processed. We can finally look at the annotation, and we can see the various information that we have to choose from to process. This is the information that will actually be drawn onto the cross-section once we hit apply. We also, on the General tab, notice that we have the Create XML Report chosen so that we create an XML report at the same time that we process our end area volumes. So let's go back to our cross-sections. And hit apply. The calculations have completed, and InRoads automatically displays the XML report choosing one of the style sheets available. Now the first time you run this, it's going to ask you for a default style sheet. In my choice, I chose this volumes.xsl as my default style sheet, which is why this automatically popped up. There are numerous other style sheets I could choose from to display the information in various formats. I tend to like the volumes XML the most. If we minimize this for a moment and we look at the sections, we'll notice that the sections are displayed with cut and fill information for the area and the volume for each one of our sections. We also have included at the bottom a running total of the mass ordinate of the cut and fill along these sections. If we look back at the style sheet, we can see the fill area and we can see the volumes for those areas. We can see the running tally of the mass ordinate. And finally, if we look down here even further, we'll see that we have the volume exception. Notice that although 9879 and 10121 both have area calculations, station 10121 does not have any volume calculations, nor does the mass ordinate change between 10121 and 9879. Thus, the volume exception processed as desired. If I wanted to, I could choose File, Save As, and save the style sheet as an HTML file, or keep it as an XML file, or in this case I can just close it because I'm going to do some more processing. Back in MicroStation, if I want to have a better idea of what I'm looking at in my sections, I can choose Settings, View Attributes, and turn on the fill. And you'll notice that by doing so, the cut and fill shapes are displayed in the cut and fill areas. That just makes it easier to see. I'm going to turn that back off. So now that we've finished our first end area volume calculation, let's jump back over to PowerPoint. When processing end area volume calculations, it's important to get the type of the surface right. As shown, we have 4 different surface types in InRoads: existing, design, substratum, and ignore. If we look back in MicroStation, we'll see in the end area volume tool we already had an existing type and a design type. Well, where did this get set? This gets set with the surface. So if I go back and look at my list of surfaces, if I look at my existing surface, for instance, if I right click and choose Surface Properties, you'll notice that on the main tab I have a type option. And here are my 4 different surface types. So when my existing surface was created, it was important that I chose the existing surface type for the end area volume tool to calculate correctly. If I look at the PSJ surface that I created with the Robot Designer, I never set that surface type, but notice it's automatically set to design. Any surface that's been created with the Robot Designer by default gets assigned a type of design. When would I use a type of substratum or ignore? Well, we have a surface already with a substratum type. I have existing shale. Now if we look at the type of my existing shale created previously, I can see I created that with a type of substratum. We'll see later on in the demonstration how this existing shale substratum surface can be used to do calculations for other existing material layers from our cross sections. The last surface type might be good for a surface such as proposed right-of-way. Since the proposed right-of-way features have nothing to do with topography, existing or proposed, we've set it to a type of ignore. Bottom line is, it's important to be sure that your surfaces are set to the correct type when doing your end area volume calculations. It's also important that we understand how the annotation and XML reporting works. Back in InRoads, we know that we had an annotation option at the bottom. This lets me choose the various information I want displayed on my cross sections when I process the end area volumes tool. Now we're not going to get into every detail in this, but as a whole, we've got the different shapes that are going to get drawn. We can display the shape area within the shape if we chose to. We could show the cut and fill centroids. This might be important if we chose the correct for curvature method. We can display the cut area, cut volume, and fill volume separately on our section, or we can display the tabulated area and tabulated volume. Now the advantage of using tabulated areas and volumes is not only will it give you cut and fill like is shown currently, but it will also show areas and volumes for proposed component materials and existing unsuitable materials. And also, as shown, we can draw the mass ordinate if we choose to. When displaying the annotation, back on the general leaf, the imperial units for cubic yards or cubic feet determine how the volumes are displayed on the sections. This has no bearing on how the areas are displayed. The areas are displayed with square feet, whereas we have an option for the volumes to be displayed with cubic yards or cubic feet. In fact, if you look at the section, you'll notice a problem. Right now, these have been given a suffix of square yards. Well, this section can only give a value of square feet, assuming our master unit of our DGN file is feet. If we measure the area calculated, we'll see we have 1,515 square feet. Well, the value displayed is twice as big as necessary since the sections are drawn with a vertical exaggeration of 2. So if I take 1550.6 divided by 2, I get 775.3 as shown. Unfortunately, it should have been square feet and not square yards. So we can change this in the annotation to change it from square yard to say square feet. If I look over on the right side, I've got cubic yard for our display over here. If I look back on the general tab, I've got it drawn as cubic feet. Let's change this to cubic yards to match what's listed in the annotation, which is cubic yard. So we've got the area as square feet and the volume as cubic yards when drawing it in the cross section. When I hit apply, we should see these changes happen. My XML report popped up again. Let's minimize this for a moment. And now take note that since we've drawn everything with pencil mode, we don't have to delete it to redraw it. We can just hit apply every time and it's going to reprocess our end area volume calculations. Notice how the volume calculation changed because it was supposed to be a cubic yard to begin with. Back over here, the value stayed the same, but it did adjust the suffix as desired. Keep in mind, the information on the General tab of these units also has no bearing on the XML report that's generated. This only affects the volume of the annotation on the cross sections. If we reopen the style sheet of the XML file displayed in a style sheet, we can see the information displayed in here. If we go to Tools, Format Options, we can choose whether we want the volumes to be converted to cubic yards or not. Notice how the information changes based on choosing that option. Next, let's look at the preferences versus the EAV file. Well, all this information that we're storing in our end area volume tool can be saved as either a preference or an end area volume file. The preference is used for client-specific settings, whereas the EAV file is used more for project-specific settings. There's a little bit of an overlap between what controls what. My preferences control a majority of what you're going to see on the general leaf. The preferences also control the information you're going to see on the annotation leaf, since the majority of this information can be used for different jobs of the same client. The EAV file, on the other hand, would be great for handling information such as volume exceptions. Your volume exception is going to be different for different jobs for different clients, or even for different alignments of the same job for a client. To save the annotation preferences, I could choose Preferences, and I could say I want to save as, and I could save this as demo. And now whenever I want to get these preferences back, I could choose Preferences, I could load demo, and I'm back where I started. If I want to save my information in an EAV file for volume exceptions, and the other tools which we'll look at shortly, such as unsuitable materials by feature, unsuitable materials by station, all my classification information, compaction and expansion values, pretty much everything between here and here gets saved as an EAV file. And it's one EAV file for all these options. So to do that, I can say File, Save As, and I can choose the EAV file I want to make. Maybe we'll call this Test 1. So now, if there's no information in here for the setting, and maybe I'll just come up to a different one to show how this works. If I say File, Open, and I choose my Test 1 EAV, if I go back down to volume exceptions, it shows that volume exception. Be very careful when using EAV files. It appears when opening an EAV file that it doesn't delete information that's already in these settings to replace it. Instead, it supplements whatever's in there with the EAV file information. So now back over to PowerPoint. Now that we've done some really basic cut and fill end area volumes, let's look at making some more advanced end area volumes. For instance, let's include proposed components from our design PSJ surface. For a little bit more advanced end area volume calculation, we're going to include the components of our designed PSJ surface. So to do that, we're going to have to update the sections with the components. We're also going to look at the classifications leaf to review the settings of these proposed components. And finally, we're going to process the end area volumes, and in doing so, we're going to add some quantities in a couple of areas. Back in InRoads, I could reprocess this. I could keep hitting apply to reprocess my sections, or if I want to delete the calculations for whatever reason, if my graphic group is turned on, it'll treat all the calculations as one big entity, so I can delete everything at once. Now I need to update my components, because right now, if I come over to my end area volume tool, I don't have an option to include my proposed components. The only way I'm going to see that option is to turn on those components in my sections. So let's go to Evaluation, Cross Section, and instead of recreating the cross sections, which I could do, I'm just going to update them. So I'm going to display on the components of PSJ, and I'm going to display on all my components and hit apply. Now that my components have displayed, I can close the update cross section box, and notice now that my sections appear with these components displayed. You can see I've got base course component, I've got base course, and curb, so on and so forth. Well, now, if I close, save my parameters, and reopen the volume tool, the General tab appears unchanged. But if I choose a Classifications leaf, notice the various objects that have been created for my proposed components. It's very important to realize that the object names are created based on the styles of the proposed components of my design surface. So I have a curb style which corresponds to this curb object. The reason they do this is so we don't have an individual object for each component name in my surface, which would be way too many components, way too many objects. So just by having these components displayed in my sections, these appeared as available objects to be computed. By default, these have been given a classification of designed as opposed to the other available classifications. We're going to try to look at some more of these different classifications later. And we've also been given a mass ordinate of exclude by default. Typically, our proposed components are set to exclude since the values don't impact the default cut or default fill of our sections. These are usually different material types, and we don't want to impact the default fill and default cut. But if necessary, we could change this to include it in that mass ordinate tabulation. To do some added quantities, we're going to choose the added quantities leaf. Now the way this works is we could choose a station, maybe some certain station, I don't know, 107. We want to introduce a cut volume of 100 and a fill factor or a cut factor of 1, so there's no extra cut or extra fill. So we could add that. At that one station, it's going to be 100 cubic yards more. We could also apply this for a range. So if we did from station, let's say 115 to 120, and we put in 500, it's going to take over these stations, it's going to put an equal out that 500 between each one of those stations. So if we add that between 115 and 120, it's going to apply evenly 500 across all these stations. So now if we leave everything else the same and hit apply, we can look at our results. The XML file automatically opens. Let's minimize that again for the moment. And now since our annotation was set to tabulated area and tabulated volume, not only do we get cut and fill areas on the left at the very top, cut and fill, we also get the proposed component objects for PSJ, the structural cores, the friction cores, so on and so forth, with the areas of each one. And on the right hand side, we get the cut and fill volumes along with the volumes of the proposed objects, structural cores, friction cores, so on and so forth. And we still have the mass ordinate tabulating at the bottom. If we open up the XML file and look at it with the style sheet, we'll see the same results. So the results I see here pretty much match the results I'm going to see back over here in my annotation. Both the annotation and the XML file display the same kinds of information. Sometimes there's some minor differences in the way that the information is displayed, however. We'll try to look at some of that towards the end of this discussion. If we look into our file and we jump down to, I think it was station 105, I had the added information in here. Where's that at? There we go, at station 107. I had an added cut volume, and you can see that added cut volume right here. And that added cut volume was also included in my mass ordinate. If I jump down to station 110 to 115, I guess it was 115 to 120, notice how I have 100 in each one of these, corresponding to that 500 that was divided over the 5 different stations along the way. Oh look, I had an extra station in here. So it's just averaging the amount between these stations using that 500 cubic yards I told it to interject. So let's close the XML file. It's important to realize when doing proposed component objects that the components had to be originally created in the templates as closed shapes. If these weren't created as closed shapes and were open, then we wouldn't be computing quantities for these proposed components. So when making your templates, make sure you use closed shapes for any proposed component that you want to quantify. So let's wipe out some of the information in here. Close the box down. Let's go back to PowerPoint. Let's zoom out. Let's look at some non-standard existing material removal options. For this demonstration, a non-standard existing material is any material other than your normal cut material from your existing surface. For instance, materials such as rock or organic materials, I'm going to classify those as non-standard existing materials. We've got three different ways to account for these different material types: unsuitable by station, unsuitable by feature, and unsuitable by subsurface. We're going to go through and look at each one of these right now. So let's get started with unsuitable by station. Let's open up our volumes tool. And we'll notice on the left hand side we have a leaf for unsuitable materials by station. And what that lets us do is choose a station range within our job. We can choose the entire range or maybe a range within. That we know that we have a different material to cut starting from the existing surface coming down. So I have maybe in the cut portion when my proposed is below my existing, maybe I have a foot of existing surface I need to take out. Maybe that's topsoil. And maybe in the fill, well, I still have topsoil in those locations, so I'm going to take out a foot of topsoil there. So now the important part is I need to choose the style that I want to have removed. The style that we choose is going to represent the material that gets removed during our calculations. So we're going to choose existing topsoil. We're going to add that to the information down below. So let's choose the classifications tab to see what just happened. But we still have our existing object. We have all of our proposed component objects. Well, now we have a new object for the existing topsoil we just added. And this is automatically by default giving a classification of unsuitable. We could choose a different option if desired. We're going to leave the default unsuitable option right now. Notice that I don't have an option to include or exclude. The existing topsoil is not included in the mass ordinate, but any material that might be necessary to fill in the hole that's been removed of the existing topsoil will be calculated in the mass ordinate. We'll look at this a little bit more in detail once we process the sections. So let's hit apply so we can process this. We'll notice that again my XML file opens. Let's minimize this again. And if we look at our sections, I can see underneath my area of fill, I have an area that's a foot deep of cut from my existing topsoil removal. Notice that it's only within the limit of my proposed footprint. This is the case in both fill and cut conditions. If I look over at my calculations of my annotation, I see that I have on the left hand side, I still have all my area calculations. I don't have any normal cut. I do have a bunch of fill. I still have all my proposed components listed, and then down below I have information about my existing topsoil removal. I have the total amount of topsoil removal, 138.69. I've got the amount that's been replaced, meaning my normal fill has replaced some of this area, and I've got the amount that's not been replaced. We'll see the not replaced when we're in cut condition. Right now, notice that when I'm in a fill condition, I have to remove this material, but I also need to replace the material that I've removed. So if I look at my information here, let's do a quick check. If I check the area of my fill, I see I get 1058.96. So 1058.96 divided by 2 is 529.48. If I look over at my regular fill material, it doesn't show 529.48. And the reason for that is the amount of fill required to fill my unsuitable has automatically been included in this calculation. So if I measure this, I get 277.3. Divided by 2 is 138.65. Notice how the 138.65 matches the existing topsoil removal. If I add the 138.69 to the 529.48 determined earlier, we get 668.17. That matches the total amount of fill required for this section. Let's take a look at the XML file to see how it's displayed in there. And let's see what section we were on. We were on section 78. So if I come down to section 78, notice here now it displays the 529.47, not the total of the two numbers. It leaves the amount of the existing topsoil separate from its calculation of normal fill. To determine the amount of total fill necessary, we have to realize we need the normal fill plus the amount of replaced fill that's required for our unsuitable by station removal. So to calculate my mass ordinate information, if I start with 2692.73, negative 2692.73, and I subtract out the amount of my normal fill, 2148.06, and I also subtract out the amount necessary for my replaced topsoil, 23.05, I get 5363.84, which is the amount of the mass ordinate for this station. One easy way to know if the information on this style sheet should be included in the mass ordinate or not is we have the yes or no column on the side for whether to include that in the mass ordinate. That's why this information was not included in the mass ordinate, because it's set to a no, and the reason that's set to no is back in the classifications leaf of the tool, I will set this information to be excluded from the mass ordinate. The important concept to understand here is the information on my style sheet is separated between my normal fill and my replaced topsoil, while in my annotation my fill shows these values combined. If I look at an area in a cut condition versus a fill condition, let's look at station 84. Notice that I'm in total cut. When I measure the amount of cut, I see I get 1409.35. 1409.35 divided by 2 is 704.67. That matches the amount of cut in my drawing. So why doesn't this one have extra material for the unsuitable removal? Well, the unsuitable doesn't need to be replaced, so we don't need to include that in this extra cut. It even tells us that down below. We can see our existing topsoil removal was 138.68, and 138.69 of that, and there's some rounding in here I guess, was not replaced. But there was a portion that was replaced. Well, what portion was that? And also notice that the portion that was replaced was included in my total fill amount up top. Well, the portion that was replaced is the area in these little slivers over here. That's 299. And over here we have another one that's 299, 298. If we add them up, divide by 2, we get 3, or 299, which corresponds to the amount shown. Again, back over in my style sheet, for station 84, we'll notice that the fill was left separated from the replaced fill of the existing topsoil. Okay, let's close this down. Let's go back to our main screen here. Let's jump back over to our PowerPoint. The next topic we want to cover is how to do unsuitable by feature. The unsuitable by feature tool works very similarly to the unsuitable by station tool, except instead of indicating a station range, we indicate features within a DTM for calculating the unsuitable material removal. This feature, or features, don't have to live in the existing surface. They can live in any other surface. The elevation of that feature doesn't matter, since the existing surface is going to determine the elevation. And finally, those features must be closed shapes in that DTM, or DTMs. Let's jump back over to MicroStation to look at an example. In my topo file, I noticed at some point that maybe I had regular old soil all the way through here for my topsoil. Maybe there was an existing road that crossed through my project. Well, I might not want to do topsoil removal along that roadway. So what I could do instead is create features for the areas of topsoil removal in the areas of the roadway. To save a little bit of time, I've already created these features. And I did so using the Import Surface from Graphics tool. So if I open up that surface, let's display the features. I can see I have 3 features. 1 for the road, 2 for topsoil. Let's display those features on. And if I choose my copy tool, I can see I have a feature in here. I have a big feature outside and another feature down here. The exact size of the feature at the outside of my proposed doesn't matter because it's only going to stay within the limit of my proposed footprint, similar to the unsuitable by station tool. The style of these features is going to matter also. So when creating these features, make sure you get the style right. That style is going to indicate the material to be removed when we process the volumes. So I can have multiple features with the same style and they're going to be quantified together. So let's display off these features. Let's go back to our end area volume tool. Let's remove the unsuitable by station. We don't want to process unsuitable by feature and unsuitable by station in the same areas. My experiences have not been good when processing those at the same locations at the same time. So I'm going to remove this. I'm going to go to my unsuitable by feature. I'm going to choose the surface with my available closed features. Nice, it reminds us to use a closed feature. And I can enter a depth for each one of these features. So maybe my topsoil is still at a depth of 1. And maybe my road, maybe that's a little bit more. Let's just do a depth of 2. Let's jump down to our classifications to see how this information was entered. Notice I have existing topsoil and existing lane. Both have been brought over from the unsuitable by feature with a classification of unsuitable, which again could be changed, but we're going to leave the default. And again, we don't have an option for including or excluding. To add a little bit more complexity to this, we're going to use a cut factor 2, maybe of 1.2 for our existing topsoil. We could also put cut and fill factors for the remaining objects, and it's important to know that if I use a cut and fill factor for this existing option at the top, and then also specified cut and fill for a station range with this information would override whatever is in this top line up here. However, it would not affect these other cut and fill factors down below. So we're just going to leave the existing topsoil with a 1.2 cut factor. When we hit apply to process our sections, again our XML file opens. Again, let's minimize this. Let's look at our sections. We can see we have another foot of topsoil removal. As we scroll up, we can see the road starting to make its way across our proposed roadway. This is the existing dirt road. Notice it's thicker than the topsoil. So this makes its way across our section. The values quantified using the unsuitable by feature are the same as the unsuitable by station. So I'm not going to go through those calculations again. However, one thing to realize is that the volume calculations on the right side are impacted by cut and fill factors, whereas the areas are not impacted by cut and fill factors. If we look at the XML file, we'll see here that the areas are not impacted by cut and fill factors, whereas the mass ordinate used with the volumes are. So let's close this down. Let's remove our unsuitable by feature options. Notice by doing so that it removes it automatically from the classifications leaf. Let's go back to PowerPoint. And the final non-standard existing material removal is the unsuitable by subsurface. The unsuitable by subsurface tool works a little different than the unsuitable by station or unsuitable by feature tools. Let's jump back over to MicroStation again. If we look in our end area volumes tool, where do we pick the unsuitable by subsurface? Well, there's not an option for it in the toolbox here. This tool works by reading other surfaces that are displayed in our sections. If I look in InRoads, I have an existing shale surface. Let's look at the perimeter of that surface. If I look over here on the left side of my project, I can see I have a surface here of existing shale. Unlike the unsuitable by feature, the information in this surface is important. If I turn on the triangles, I can see that it does have elevations along that surface, and these are below my existing surface. So let's display this information off. Let's update my sections with this surface information. When I look back over at my sections, I'll notice I have a new line underneath my existing ground that represents the existing shale. If I close and reopen my end area volumes tool, I'll notice the existing shale surface is now available, and it has a type of substrata that was set previously. Simply by having the existing shale in my surface, if I look at the classifications leaf, I can see the existing shale is available to be processed. Now, unlike the existing by feature and existing by station, the name of the DTM is what impacts the object, not the feature names inside that DTM. A couple of benefits of using this tool over the by feature and by station tool is that the surface can actually be a distance below ground. So there might be regular fill for the first maybe 3 feet or something, and then maybe after that, maybe it's shale or some other surface that is different than our normal cut, normal fill. In addition, unlike the other tools, the depth relative to ground can vary with this tool, because we can have a surface that goes up and down and anything we want it to do, just as long as it doesn't poke above my existing surface. It's also important to realize that the surface displayed represents the top of my unsuitable surface, not the bottom of that surface. This is different than other software packages I've used previously. Still looking at the classifications leaf, we can see that the classification was automatically given an assignment of rock. Again, we could change that if we desired. And it was chosen to be included in the mass ordinate. Now with the other unsuitable options that we used previously, we didn't have an option for mass ordinate. Well, this time we do. So we could either include it or exclude it. By leaving it included means that the materials that are removed for existing shale can be included in our running tally of our mass ordinate. This is probably more common for surface such as rock that can be reused along our project. However, if we were removing maybe an organic material, we might choose to exclude that from the mass ordinate since we wouldn't want to reuse that material. So let's process this. Let's minimize the XML. Notice that in this cut station, if I measure the area of the normal cut, I have 566.5 divided by 2 is 283.25. If I measure the area of the shale removal, I have 917.3 divided by 2 is 458.65. Notice that it quantifies the existing shale removal, and it also includes that amount in the total removal. So if I add my values, 458.65 plus the 283.25, I get 741.9, which shows my total removal. If I had used the exclude option, this would only show the 283.25, since the shale wouldn't have been included in my mass ordinate. Don't forget, if I was to open up my XML file, or my style sheet that shows my XML file, the information for my cut and my shale removal will show separately in that XML file. Let's take a look at a fill condition. If I measure the area of my fill, I get 702.06. Divided by 2 is 351.03. And that corresponds to the fill information shown. So why didn't I have any existing shale removal? Well, I didn't have a cut condition, and none of my proposed components interacted with the shale condition. To interact with the shale, I'd have to have information or proposed objects below this yellow line. I don't have that, so I'm not going to get any existing shale. Unlike the previous unsuitable material tools that would remove unsuitable materials regardless if I was in cut or fill. So let's maximize our screen and jump back over to PowerPoint. Now that we're done with the non-standard existing material removals, let's take a little bit more at that classifications leaf. The classifications leaf is really the control center of the end area volumes tool. Adjusting the different ways that the mass ordinate, the classifications, and the factors are applied can really affect the results that are determined. Let's just pop back over in the time that we have and look at some of these options. Well, we've already looked at the mass ordinate. Hopefully we have a basic idea how that processes if we didn't know how that worked previously. We also took a brief look at the cut and fill factors and how that affects the volumes that are processed. What we haven't spent a lot of time on are these classifications. Many of these classifications are set by default when you add an object to the classifications leaf. For instance, when we add these proposed components, they were automatically added as designed. When we added the existing shale, it was automatically added as rock. We can change these classifications at any time, and what you choose may affect how the results get processed. For existing information, if I change it from rock to unsuitable to unclassified, it's not really going to affect the results. It wouldn't make sense to change it to designed or MDC since these are proposed classifications. By setting an object to ignore means that that information will not be displayed in the annotation or in the XML file reports. You've got to be careful though, because objects that have been set to ignore still affect other quantities during the processing. For instance, the existing shale is currently set to ignore. If I am in a section that's in cut that gets into the existing shale surface, the information that's above the shale surface will process as cut as normal. However, the information below the shale will not be displayed as shale. It will not display as regular cut since the existing shale is present but set to the ignore classification. If I really chose to ignore a certain surface, I could always come back to the General tab and uncheck existing shale completely. If I look back at the classifications, I can see that it's completely removed and the sections will process the volumes as though the existing shale is not there at all. Back in my classifications for my proposed components, I wouldn't want to choose unsuitable or rock for proposed because those are for existing information. If I chose something other than designed, which is a default, I could choose the MDC. Now the MDC is kind of a complicated way of separating the unclassified versus the subcut information when proposed objects are placed. So the MDC determines whether or not the proposed object cuts into an existing surface or not when it's placed. In summary, I hope you've learned enough that you feel a little bit confident with the end area volume tool. Just to sum things up, we looked at how to process design surface components, some various methods for processing the unsuitable material layers. We looked at some other things such as preferences and EAV files, and hopefully we understand a little bit about the computations used with the annotation and the XML file results. This concludes my presentation on InRoads XM Edition End Area Volumes tool.